Okay, in descriptive statistic, I will show you on how to construct the frequency table and also how to generate the pie chart and bar chart for the qualitative data. Okay, you can go to analyze, okay, and then choose the descriptive statistic and then go to the frequencies. Okay, and then let's say you want to construct the pie chart, okay, for the gender. Okay, so select gender and then click the right button, okay, to the variable, and then make sure that you check the display frequency tables, and then for charts you choose the pie charts. Okay, so the chart values you choose the percentages. Click continue and then just click OK. Okay, so you can see that this is the frequency table. So you can see that there are 8 male and 16 female with a total of 24 respondents. Okay, so you can also see that 33.3% okay, of the respondent are male, and then another 66.7% are female. Okay, so this is your pie chart. If you want to amend your pie chart, okay, you can just double click, okay, and then you just select. You can see that there is the line, the grey line, okay, outside the bar chart. Okay, so let's say if you want to change the color, okay, of the red one here, so you just click once, okay, so you can see that the grey line here is only select um the the red slice. Okay, so you just can right click, okay, and then choose the property windows. So if you want to change color, so let's say you want to change to turquoise, okay, and then you just choose the color that you want to, and then just click apply. Okay, and then if you want to change the color for the blue one, okay, so you just click the blue slice, okay, and then you choose, okay, the color that you desire of. Okay, so let's say I want to choose the mustard color, okay, and then just click apply. Okay, and then after that, okay, you can display, okay, your pie chart, okay, in 3D form. So you just click 3D, okay, and then you can also change the position, okay, or the angle, okay, of the pie chart. Okay, so let us see first, okay, how does the 3D look like. Okay, apply, okay, and then if you want to change the angle, okay, so that it can be seen clearly, okay, and then just click apply, okay, and then you can just click close, okay, and then if you want to have the data labels, okay, so you can just choose here, you can right click and then choose the show data labels. Okay, so what to be displayed here is the percentage. Okay, if you want also to display, okay, the gender, so you just click the gender here and then click the up button, okay, and then apply. Okay, so you can see that the percentage and the fit and the legend, okay, on the pie chart. Okay, and then if you want, let's say if you want the male on the top, okay, and then the percentage, okay, below the title, okay, so you can just put the gender up here, okay, and then apply. Okay, you can close, okay, and then if this is your graph, okay, then you don't need this one anymore, so you can delete the title, okay, and you can also hide the legend. Okay, so you can just right click and then hide the legend, okay, because this is already being labeled. Okay, and then you can just close, okay, and then you can copy paste this one. Okay, descriptive statistic, quantitative variable. For the quantitative variable, so we can produce a summary of statistic and visualize it using the box plot. To do that in the SPSS, okay, you can go to analyze and then choose descriptive statistics and then choose the explore. Okay, for the dependent list, you can choose the price elasticity. And then for the display, we want it to be statistics and the plot. So we choose both. And then for plots, okay, so you can untick the stem and leaf and then just choose the factor levels together. And then you can click continue and then okay. So this is the output, okay, from the descriptive statistics. You can see that we have the mean value. So you can see that on the average, the price elasticity score is 4.09. Okay, and then the 95% confidence interval, you can say that on the average, the price elasticity score is between 3.85 and 4.33. Okay, and then you can also report the median. So you can see that 50% okay, of the respondent, the price elasticity score is above 4.08. And then another 50% of the respondent, the price elasticity score is less than 4.08. Okay, and then we have the variance and the standard deviation. So normally the standard deviation will be reported together with the value of mean. Okay, and then we have the minimum and the maximum. So you can say that the lowest score of the price elasticity is 3, and then the highest score is 5. Okay, and then you can also report the skewness. Okay, so you can see that the skewness is negative 0.219. So actually this is approaching to 0. So you can see that the data actually approaching to normal distribution. Okay, but if you want to say that the data is a negatively skewed, is also acceptable because you can see that the skewness value is equal to the negative. Okay, so this is the plot of the price elasticity score. So you can see that the data seems to be normally distributed. Okay, approaching to normal distribution. So you can describe, okay, the price elasticity is normally distributed. One sample t-test. Okay, we try to test, okay, whether the price elasticity score is greater than 4. Okay, so to do that, okay, you go to analyze and then choose the compare means and proportions. Choose one sample t-test. Okay, and then for the test variable, you can choose the price elasticity. And then the test value you can type equal to 4. Okay, so we want to test whether the price elasticity is greater than 4. Okay, you can untick the estimate effect size. Okay, and then just click OK. So this is the result of the one sample t-test. Okay, so actually this is the current version of the SPSS. So they provide the two value of p value. So this is the one-sided, this is the two-sided. Okay, the old version of the SPSS provide only two-sided P. So you need to divide by 2 to get the one-sided P. Okay, so if you want to test, okay, whether the price elasticity score is greater than 4, okay, so you use the one-sided P. Okay, because we want to test the mean, okay, is greater than 4. Okay, so of course you can see that the p value here is not significant. The p value is greater than 0.4 greater than 0.05. Okay, sorry, here 0 the one-sided p 0.225 is greater than 0.05. So therefore fail to reject the null hypothesis, and then we can conclude that okay, there is no enough evidence the price elasticity score is greater than 4. Two independent sample t-test. Okay, for comparing two means, okay, let's say if I want to compare the price elasticity between gender. Okay, so there are two categories here. So we use the independent t-test. Okay, remember because there are two groups, okay, male and female. Okay, so to do that in the SPSS, so I just go to analyze, choose the compare means and proportions, and then choose the independent sample t-test. Okay, and then for the test variable, so we put the price elasticity. Okay, and then for the grouping variable, so we use the gender. Okay, so we know that we already code the gender for male equal to 1, female equal to 2. So in the defined group, so you just can put group 1 equal to 1, group 2 equal to 2. Okay, if you use 0 to represent male, so you can choose group 1 equal to 0, and then 1 for female, so group 2 is equal to 1. Okay, then just click continue. Okay, and then you can untick the estimate effect size, and then just click OK. Okay, so this is the result of the independent sample t-test. Okay, so you can double click if you want to transpose it. Okay, so that it is easily to be seen. Okay, so you can see here, okay, this is the 11 test. So 11 test is to test whether the variance for both group are equal or not. Okay, so if the p-value in the 11 test, okay, is greater than 0.05, so which means that the variances are equal. Okay, so the analysis for the independent t-test, we will refer to this column only. Okay, so you can ignore this column. Okay, because based on the 11 test, the p-value greater than 0.05, so which assume that the variances are equal for both group. Okay, and then from here, okay, you can get the test value. The degree of freedom equal to 22. Okay, and then the p-value. Okay, so actually this is the p-value. So the new version of SPSS provide the one-sided p-value. So if you want to test whether the mean for the price elasticity score for male is greater than for female, then you can use the one-sided here. Okay, or else if you want to see is there any different or not in the price elasticity between male and female. Okay, so you can just take the value of the two sided here. Okay, and then from the confidence interval, you can see that, okay, the confidence interval, there is a negative and a positive value. Okay, so and then 0 is not in the confidence interval, so you can confirm that there is no significant difference, okay, in the price elasticity between male and female. Dependent samples t-test. Okay, for the two dependent sample, let's say we want to test, okay, whether is there any difference or not, okay, in the spending money on groceries during the pandemic and then the after pandemic. Okay, so we have the information, okay, regarding how many you spend during the pandemic and then the after pandemic. So we want to see is there any difference or not. Okay, so to do that, okay, you can go to analyze. Okay, and then choose compare means, and then choose pet sample t-test. Okay, so remember that, okay, in this question we ask the same respondent, okay, the amount of they spend during and after. So suppose that these two values come from the same respondent. Okay, so let's say we put here pair 1, variable 1 is the groceries during, and then the variable 2 groceries after. Okay, just untick the estimate effect size and then just click OK. Okay, so in the pet sample t-test, okay, they provide you the summary of statistic, okay, for each pair. So this is the summary of statistic during the pandemic, and then this is the summary of statistic after the pandemic. Okay, so you can see that on the average before the pandemic, Okay, they spend on the during the pandemic, they spend on the groceries about 203 ringgit. And then after the pandemic, okay, on the average, the respondents spend about 250 ringgit and 54 cent. Okay. So this is the pet samples correlation. So normally we can ignore this part. Okay, and then we just refer to this pet sample test. Okay. So we can see that, okay, if we test, okay, at 5% level of significant, okay, so we refer to the two-sided, so there is no significant difference, okay, on the money spent, okay, during pandemic and after the pandemic. Okay, if you because the p value here, okay, 0.083 is greater than 0.05. Okay, but if you test at 10%, so there is a significant difference. Okay, but if you test at the 5%, so of course there is no significant difference. Okay, and then the confidence interval also, okay, since you contract the 95% confidence interval, so the lower value is negative 109, okay, and then the upper 7.166. So there is a zero in between here, okay. So therefore there is no significant difference, okay, in the money spent on groceries during the pandemic and after pandemic. ANOVA. Want to compare more than two groups, okay, you can use the ANOVA. So in this case, if I want to compare, is there any difference or not, okay, in the price elasticity between those respondents who from suburban, urban and the rural area. Okay, so I just can go to analyze and then choose compare means and then choose one way ANOVA. Okay, so the dependent list will be the price elasticity. Okay, and then the factor is the hometown. Okay, and then you can just untick the estimate effect size and then choose OK. Okay, so this is the result of the ANOVA. Okay, so you can see that, okay, the seek value here 0.277, so which is greater than 0.05. So we can see that there is no enough evidence and the price elasticity is different among the hometown. Correlation. This is, I want to find the whether is there any correlation or not, okay, between how much they spend on food during the pandemic and the groceries during the pandemic. Okay, so to do that, I just go to analyze, okay, and then choose the correlation, okay, and then click to the bivariate. Okay, so I just choose the food, okay, and also groceries. So the correlation coefficient, I use the Pearson. Test significant, use the two tail. Okay, and then after that, you just click OK. Okay, so based on the correlation analysis, you can see that there is a moderate correlation, okay, between on how between the money the respondents spend on the groceries and the ordering food from the e-hailing. Regression analysis. Okay, let's say if we found that there is a relationship between spending money on e-hailing food during pandemic and spending money on the groceries during the pandemic. Okay, so we want to find the model. Okay, find the model of the food here. Okay, so we want to see if they spend money, whether if they spend the money on the groceries. So how much they will spend money on the food e-hailing here. Okay, so I just go to analyze, okay, and then choose the regression, okay, and then go to the linear. Okay, so the dependent variable, okay, will be the food, okay, because this is actually what we want to determine here. Okay, and then the independent variable is the groceries. Okay, and then you just click okay. Okay, so for the SPSS output on the regression analysis, okay, so you can see that, okay, there are 4 outputs. Okay, so you can ignore this output and then refer to the model summary. So it provides you the value of R, okay, the R squared. R actually is the coefficient correlation. However, if the value is a negative value, it doesn't appear, okay, the value of R. And then we have the R squared, okay, the coefficient of determination. So these two need to be understand. Okay, and then you can ignore the ANOVA table. So the important thing is the coefficient here. Okay, so the coefficient here provide the value of the constant here 26.920. This is the value of beta null, and then this part is the value of beta 1. Okay, and then if you can see this value, the standardized coefficient beta, this part actually is the value of the R. Okay, so this value and this value might be different in terms of the sign. Okay, so the R in the model summary might not be it won't return to you a negative value if it's a negative relationship, but the standardized coefficient beta will give you the true uh, sign, okay, of the relationship between the two variables. So therefore, the equation that you get, okay, supposed to be, okay, y is equal to 26.920 plus 0.42x. Okay, where in this case y is the how much you spend in ordering food from the e-hailing apps. Okay, and then x, okay, is how much do you spend on groceries during the pandemic. Okay, test of independent. Okay, if you want to determine whether is there any association or not between between two categorical variable, then we can use the chi-square test. So let's say in this example, I want to find whether is there any association or not between gender and the hometown of the respondent. Okay, so to do that in SPSS, you can go to analyze. Okay, choose descriptive statistic and then go to the cross tab. Okay, and then for row you choose gender, and then for column, so I choose where is your hometown. Okay, you can click cells, okay, and then actually the observe have been ticked, so you just tick the expected value here. Okay, and then continue, and then after that you go to statistic and then choose the chi-square. Okay, so that you produce a chi-square test. Continue. You can also produce a cluster bar chart, okay, by clicking this box and then just click OK. So this is the cross tabulation, okay, of the male versus the hometown of the respondent. Okay, so we have the count and the expected value here. And then this is the chi-squared test. So we refer to the value of Pearson chi-squared, okay, and then we refer to the p-value here. Okay, so if the p-value less than alpha, reject the null hypothesis. However, in this case, our p-value 0.668 is greater than 0.05. So, fail to reject the null hypothesis. Okay, so therefore, there is no association. Okay, we have no evidence to conclude that there is an association, okay, between gender and the hometown. Okay, so this is the cluster bar chart, okay, of the male versus the hometown. So you can see that, okay, the distribution of the hometown, okay, according to the gender.